should be really familiar to you, actually. Right? Secant and cosecant are the reciprocals of sine and cosine. In other words, all right, it's sine and cosine, but flipped, right? Okay? And since we're in the season of Halloween, this is the perfect time to talk about this because secant and cosecant is the ghost function of sine and cosine. Yes, I know. Okay, so here we go. Let's talk about secant, right? All right. To do secant, to graph secant, you need to use the graph of cosine. If you remember, cosine goes from 0 to 2 pi. Remember that? Yeah? In the middle, pi. Then pi over 2 and 3 pi over 2. We need 1 and negative 1, right? Okay. Here's where you use your colored pencil for this one. All right? Use your colored pencil for this one. Yeah. All right. Cosine with your colored pencil starts at 1, then 0, then negative 1, then 0, then back up to 1. Right? Okay. With your colored pencil, we're going to create the ghost function. Since it's a ghost function, it's not actually there. So instead of a solid line, we're going to use a dotted line. So make a dotted version of cosine. Like that. Ooh, it's a ghost. It's a ghost. Yeah, with your colored pencil. Okay. Yeah. Got it? Oh, excellent. Okay. Now, here we go. Highlighter, highlighter, highlighter. Right? Where the cosine crosses the x-axis, right here and right here. That is the position of the asymptotes. Okay? So with your highlighter, you put asymptotes where the line crosses the x-axis. In other words, the middle between the high and the low point. Because sometimes, especially when you do a shift vertically, it won't always just be the x-axis, right? So it's the highest and lowest point. Those are asymptotes. Okay. Now, here we go. With your pencil or a different color, we draw the stuff in between. Now remember what the asymptotes do. They draw the graph towards them without even touching. So from this point, this graph will be drawn toward that asymptote, right? From this point, it's going to be drawn to this asymptote and this asymptote. What shape is that? It's a parabola. So secants and cosecants are just parabolas because they're the flip of sine and cosine, right? If we were to continue this, Miss Page, right? If we were to continue secant like so, right? You would have more asymptotes going on. So let me get the highlighter, right? So somewhere around here and somewhere around here, you would have another asymptote. Oh, and over here as well. Right? So you can continue. I'm just going to draw out a different color. You don't have to draw if you want to. But basically, this pattern continues on. Up, down, up, down, up, down. Like so. It's just a bunch of U's. Yeah? Okay? Again, the secant is the flip of the cosine. So whenever you had a hill for cosine, it turns into a valley. Whenever it was a valley, it turned into a hill. It flipped. Oh! Right. Okay. So it's just at the highs and lows. That's it. That's it. Yeah. Okay. I'm traveling really fast. Shall I slow down? I'm sorry. Sorry. Back. There you go. Yeah, I'm just getting so excited. All right, Also notice, remember that cosine starts at -1, so the first u is going up like at -1. You can tell. Yes, love. That's the actual graph. Yeah. Would you like to actually see it? Let me show you. Let me show you. It's okay. Well, you know, it's all good. All right, so let me do this. If this works, maybe. It didn't work yesterday, so. What else is broke? Your heart is broke? Sad face. Oh my goodness gracious. All right, maybe this doesn't need to be on YouTube right now. Okay. What do you do? What do you do? Here we go. So for example, right, cosine. If you do cosine x, then I'm just going to show you how to graph this one real quick. Zoom trig is 7. So that way it graphs the trig function. All right. The blue? Yay? Woo! There it is. Okay, so that's cosine. Comparing that to the reciprocal of cosine, and since I can't do secant, it's going to be 1 divided by cosine. True? Yeah? Okay, this is going to be in red. Woo! So every hill becomes a valley, every valley becomes a hill. So if I were to get rid of this function, let me just unclick it so that way it doesn't graph. Then this is actually what what the secant looks like.
So which one you want us to write?
Well, that's why I made you do everything that is not part of the function as a dashed line or as a highlighter. The solid ones is the actual graph, right? So you can keep your ghost function and all the little pieces that you need to create it. That's fine. But the solid U's are the actual graph of secant and cosecant.
We're gonna have a test, right?
Yes.
So
Yes. Yes. Yeah. I don't expect you to erase the ghost function. Yeah? Good. All right. Here comes Peter. Hello, Peter. Peter. All right. Peter. There's a segment of the video where everyone's saying Peter. All right. Here we go. Sine. Sine is the reciprocal of cosecant, right? Cosecant? I had it backwards. Here we go. So here we go. Set up your graph. Remember, sine goes from 0 to 2 pi. Pi over 2. 3 pi over 2. 1. Negative 1. That's why I say a goose. Sounds like a goose. What? Alright. That's strange. Okay, here we go. Colored pencil time. Colored pencil time. Sine goes 0, 1, 0, negative 1, 0. So, ghost function. Ghost function. Just in time for Halloween, man, let me tell you. My timing is amazing. I'm sorry. I think I did that once. Right? Okay. Here we go. Where are the asymptotes at? Pi, definitely. 2 pi. Oh, there's another one. Hang on. And 0. Thanks. That's why I made you the highlighter for 0, because you won't be able to see the asymptotes other than that. So pi, 2 pi, and 0. All of the middle points between the highs and lows. Those are all asymptotes. Yeah? Okay? Now, pencil or whatever solid color you're going to make the actual function. Remember that the asymptotes drag the graph to it, and that's what makes that beautiful parabola shape. That's good stuff. You taught yourself trig. That's good. Woo! Excellent. 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 You always learn better if you teach yourself. Yeah, it's true. It's true. Or if you try to teach somebody else, you know it better. Right? Yeah. All right. Here we go. Little cheat sheet for you. Okay, at the very bottom. Okay. If you're going to graph, let's see, right? If you're going to graph secant, right, then you're going to use cosine. Yeah? Okay? If you're going to graph cosecant, then use the ghost function of sine. Other than that, everything else is the same. You still find all of your intervals the same way, right? And then you do all that chart stuff. It's just that this time, when you do sine, it's a ghost function, and then you finish up with the valleys and the hills being flipped. Yay?
Oh.
Yay! I know. It was great. It was great. Okay. 2 with me, then 6 on your own, and then you're ready for a test. I believe. I believe. Okay. Here we go. Question. What is my ghost function for this one? What is it? Cosine. Right? We're going to use the cosine to graph this one. Okay. So 2x is still going to be between, hello? 0 and 2 pi. I think it's delayed. All right. Solve for x, so divide by 2. So 0 is less than x is less than pi. Right? Okay. So we go from 0 to pi. Pi over 2. I feel like we've done this a few times. Pi over 4. 3 pi over 4. Yay! All right. Remember, we're using cosine. Oh, shucks. Oh, 1 plus, this is 2 over 2, so 1 plus 2 is 3, and since it doesn't divide, it's 3 pi over 4. Yeah. Cosine goes 1, 0. Yeah, -1. I'm sorry, I doubted you for a second. Sorry. Yeah. Then multiply by 3. So 3 cosine makes it 3. Gorgeous. Okay, so this is our ghost function. From 0 to pi, between is pi over 2, pi over 4, and 3 pi over 4. We're going up 3 and down 3. Yeah? Okay. Colored pencil, colored pencil, colored pencil. You're already done? Oh my gosh. 3, 0, -3, 0, back up to 3. Ooh. Woo. Where's my? There it is. There it is. I ran out of ink. Yeah. What you need? 0.7. Use this instead. Just use a different color. Oh, you need a different color. Good. You need a different color. That's all. You just need a different color. That's all. Oh my goodness. All right. Here you go. No tackiness. No tackiness. I only gave that to you because that's already sharpened. All right. Where are my asymptotes? Yes. Oh my gosh. You guys caught on to this like fast. I am so impressed. They caught on to it fast. Well, Eddie, you know. What you gonna do? Alright. So at pi over 4 and 3 pi. Oh, stop it. Stop it. Highlighter. This one. Okay. Pi over 4. 3 pi over 4. Okay? Now your solid color makes a U where you have a valley and actually where you have a hill and like that. And that's just half of the other U. You know that it continues on forever and ever. Yay? Yes. You can do a half of you.
Anytime
Yeah.
plus the x is where the asymptotes go.
The middle dots between the higher and lower. Because the next one, we're going to, there's some of them where you shift it up and down. So if you shift it up and down, then the middle dots won't be at 0 anymore. They'll be like wherever the middle dots are, right? So the dots between the highs and lows are asymptotes. You know what I mean? Yeah. No, so let me show you, right? So see these dots right here, these two dots are between the high point and the low point. So that's where the asymptotes are.
Oh, halfway.
Yeah, the halfway points.
It's not always equal.
Not necessarily, because what if you have a shift? Like what if it all moved up, right? Okay. All right, here we go. For this last one, which function are we using? Sine. Yes. Here we go. We're going to use sine. All right. So x plus pi over 4 is between 0 and 2 pi. Oh, I feel like we did this one today. B minus. So if you, right, if you're still having a hard time with this, remember 2 pi is just 8 pi over 4. True? Yeah. Okay. So the first one is negative pi over 4 to x. I'm just being lazy and not putting equal to. We should, but whatever. 8 minus 1, 7. Team 38. Okay. All right. Here we go. Negative pi over 4 to 7 pi over 4. All right, Max. Do we add or subtract them? The atom. Thank you. P.S. That's my husband's name. Don't you love it? It's so mathematical. Atom. Here we go. Negative 1 plus 7. 6 divided by 2. 6 divided by 2 is 3. Very good. This middle one is 3 pi over 4. Yeah? Negative 1 plus 3. 2 divided by 2. 1. So this is just pi over 4. Yeah. 6 plus 7. 10 divided by 2. 5 pi over 4. Wow. Wow. Okay. We're doing sine, right? Sine starts at 0, 1, 0, negative 1, 0. Then times it by half. So times a half of sine, 0, 1 half, 0. Woo! Yeah, negative 1. Oh, no, times by half. Sorry, Josh. You're right. That's go. Oh, wait. Just a half. Just a half. Thank you, son. All right. So we have stuff on the left side. No big deal. Negative pi over 4. Pi over 4. Oh, boy. Yeah. There we go. If that's 1 and negative 1, then we're doing the halfway points, right? I just put the 1 and negative 1 just to, like, a reference. You don't have to put it in there. All right. Color pencil. Yay? Okay. 0. Now watch it. Remember, 0 isn't the next angle. It's 1/4. So make sure you follow that. I always mess that up, too. There we go. 0, negative a half. 0, dot, 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 dot. Still catching up to me. Wow, it's like a ghost. All right, here we go. Highlighter, highlighter. Where are my asymptotes? Yes. Yes. Oh my gosh, Fatima. You did it already. Oh, you're so good. Da, 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 da. Turn to your neighbor and say, this is cake. Okay, it's not fake. It's not fake. All right. All right. Here's what I want before you leave today. Before you leave today, I want these 6 questions, right? Just those 6 questions. I'll go back and say it. Here we go. Just do 3 to 18 by 3s. Make sure you fill out that cheat sheet before tomorrow because your test is tomorrow. Yay! time. Donnie, you got this, bud. You got this.
It's not a good time.
It's a good time.
It's really
It's a great time, some would say.
Oh wait, you don't have to call me that.